Hi, everybody. Thanks, Kirsty. I guess I'll get right into it. I'm going to be talking to you guys today a little bit about an introduction to kind of open and reproducible neuroimaging, and kind of the state of the world, but also how you can get started. But before I do, I just want to give you a little bit of an overview of the symposium that you're going to see as a whole. So first, as I said, I'll give you a bit of a getting started. Then Elizabeth's going to be stepping in with talking about open publishing. Russ is going to talk a little bit about the evolution of open science in our community. And then Kirsty's going to be talking about inclusion. So in my talk, I'll start by telling you a little bit about, what am I actually talking about? What does open reproducible neuroimaging mean? Or at least to me. What is open by design, some recommendations that have been made towards this. Talk about some data and some tools and some case studies of kind of how you can be open. Ask you if we've actually solved this problem, and then maybe talk a little bit more about some training and wrap things up. So, for starters, open reproducible neuroimaging. Let's break this down word by word. So by open, simply put, sharing is caring. And I don't necessarily mean, generosity, giving it to your friend, being nice. I mean sharing is caring about our science. It's really important, for the sake of evaluating claims and evaluating their trustworthiness and, essentially building on the work of others, that this is all done transparently. It's important that, analyses are shared, data is shared, tools are shared, so that we really know what is being put in, the papers in front of us. If we can't critically evaluate the methods and the data sets, how can we critically evaluate the claims? So, once these things are made available to us, can we actually still get the same answer? So this is a reproducible portion. So again, if I say collected a similar data set and maybe use the exact same tools or use similar tools on the same data set or a similar data set, does the answer hold up? And again, it's impossible without this open component to evaluate if that isn't the case, why isn't the case? Is it because of, again, differences between tools, differences between data sets, sample bias, misreporting, whatever, or is it, something we can actually put our finger on? And neuroimaging, well, we're at OHBM, so I'm sure you all are fine with me skipping a definition of neuroimaging. So one thing that came out this past year was, in 2018, was a recommendation of open science by design. This was created by the National Academy of Science, Engineering, and Medicine in the United States. And what it aimed to do was kind of address some of the challenges, barriers, and kind of provide recommendations for how to do open science moving forward. So again, the point of this is to make it so that science is synonymous with open science. And again, part of this is by planning for it to be open from the beginning and not making it open as an afterthought. Once your manuscript gets accepted and the journal says, oh, quickly you have to share your data. And importantly, this talks about some of the challenges in doing this and provides, again, recommendations for how to move forward. So one topic that's recommended pretty heavily in this document is the FAIR principles. So the FAIR principles, for those who haven't heard of them, were proposed or kind of recommended from the Force 11 conference a couple years ago, which is a publishing conference, and they are findable, accessible, interoperable, reusable. And this is saying that, making resources open isn't necessarily good enough. They have to be open in a way that's actually useful. So, if you follow these principles, if you make it so that, they're persistent, they're findable, people can actually get to them. If they're accessible, so they're, gettable in a way that's actually kind of consumable, so you're not necessarily using obscure standards that are hard to use. Interoperable, so, they're well-defined, they're using community standards where available. And reusable, again, kind of bringing these together. There's a little bit of overlap between these terms. But the point is that, being open isn't good enough on its own. You have to be open kind of the right way. And so that's what the FAIR principles are trying to get at. So the pieces here are, we can think about, okay, we want to make our data fair, we want to make our tools and analyses fair, and we, of course, want to publish fair articles. So I'm not going to talk about publishing because Elizabeth will do that shortly, but I'll try and give kind of short examples for the first two. So great. So we're going to talk about just one tool that is, becoming more popular in our community, made by Yaroslav Halchenko and Michael Henke primarily, and this is DataLad. So say we want to, create a data set and publish it. Great. So, we can put it into DataLad, and we see down here in the bottom, there we go. We can see down here in the bottom, we have some archived version of this data set. So then, we make changes to it. We say organize it into a new format, and, we publish that updated version. So now it's in BIDS, which is a standard many of you have heard of by now, and we publish a new version. Then we perform some pre-processing, same thing, do some analysis, do some paper, all of that. And so each of these versions of our data set are kind of frozen in a snapshot, and we can save them, and the provenance of what you've done to your data is very transparent and clear, so that somebody who looks at the end, who looks at paper A or paper B, can go all the way back up the tree and understand where you started from. Cool. So maybe we started we're doing okay with the data. So now let's think about tools. So again, this is just another case study. This is using a tool that Tristan Gautard at Concordia, one of my co-supervisors, develops, and I work on with him. And this is using boutiques. So this is for tools. We're going to say, you create a tool that's really useful. It's the best pipeline ever. You're really excited about it. So then you can describe it using this description framework that we've made. You can publish that descriptor on Zenodo, which is a persistent database created and made available by CERN. Then people can search for these tools, can download them, can look at a bunch of different documentation about them, can test them, simulate them, so on and so forth, deploy them in high-performance computing environments, and really kind of go through the entire, again, fair process with your tool very easily. Cool. So now we've talked about fair data and fair tools. So we've really kind of tackled both these pieces. And again, I've already told you, Elizabeth's going to tackle the fair publishing in a second. So is this problem solved? Well, I think not quite, because we're missing one very important piece, which is training. And making use of all of these different tools, it can be difficult. It's not easy to say I'm, a neuroscience student or I'm an engineering student who's never been trained in computer science, and all of a sudden now I have to learn about, directed acyclic graphs and build trees and store my data in all these complex ways. So there's a few ways that this is difficult. So for starters, it takes time. And it takes a lot of time in the short term because, we always have deadlines. There's a grant, there's, a student graduating, whatever. And it's never convenient, or it's very rarely convenient to say, I'm going to stop my analysis, and I'm going to go and learn this new technology, and again, put all my data in this framework. But, in the longer term, so the counterpoint to that is, of course, in the longer term, when you get feedback from a manuscript and you need to tweak an analysis, or when a student leaves and their hard drive just mysteriously disappears, you don't essentially get setbacks from these anymore because you have persistent data, because you've made it interoperable and reusable, not only by those students themselves in later iterations, but yourself. So another problem with this is, okay, so now maybe I've convinced you, sure, it's a down payment of time, but at the end of the day, when you become used to these tools, they make your life easier and they make your kind of analysis more efficient. But it still requires a lot of learning, and there's a good chance that not very many of you are computer scientists. I'm not a computer scientist. So again, learning some of these things can be very daunting. I know as an example, I was intimidated by DataLad for months after I first discovered it because the commands just scared me. I can't really explain why. I've used harder tools, but I was just afraid. And I think it's not a unique feeling for that or another tool. Sorry to throw you guys under the bus. I didn't mean to. But the point is, there are resources to help with this. So I'm going to talk about a few of these that the Open Science SIG has done both presently and in the past. And then some other resources kind of separate from the SIG and OHBM in general. So one example of a way that we're trying to kind of bridge the gap between these tools and the communities that we hope to use them, again, is through these training workshops. So one of them is BrainHack 101. So BrainHack 101 for the last several years has been run on Educational Sundays as part of OHBM. I ran it for the first time in Vancouver, which was 2017, and I've been running it for the last 2 years as well. So again, the point of this is to essentially provide a place where people can come, they can ask questions, they can essentially know what to Google. This isn't meant to be, a one-stop shop, we're going to fix all your programming needs. We're going to say, here are some basics or some core tools that will be able to help, and here's kind of how you find out information about them. So then another thing that was actually created last year by Anisha Keshavan and I when we were co-chairing the OHBM hackathon was the train track. So the idea with the train track is that we have these big hackathons, as many of you may be aware of, ahead of the OHBM meeting. And so this past year, we decided we were going to grow a lot bigger. And part of that meant we were going to have a bunch of new people who hadn't necessarily been in this community before. So given that, we wanted to find a way to onboard them. So in parallel with, the hacking with the regular workshops and, with the regular unstructured time and working on projects, we would have structured, digestible chunks of learning tools and essentially showcasing this. And so the students had a chance to not only, again, be exposed to new content, but to practice with it. And similarly, in the last few years, the Open Science Room has really kind of exploded as a place for people to learn. Again, so I believe it was started, I think in Geneva, maybe the year before, and essentially what it's evolved into is this really rich schedule where all of the content is community-driven, publicly decided on GitHub. People submit requests for tutorials or proposals, people vote on them, people have discussions. As you can see, every one of these threads has multiple comments on it. And then eventually, you know, through democracy, we arrive at a schedule. So again, this is a way that people can also have, not just have, you know, useful discussions about the future of things like bids or other standards, but they can actually have tutorials and demos and things like that as well. So these are just the things that, you know, the Open Science SIG in particular has been doing and spearheading. But, you know, we are by no means the only ones who are trying to do this and tackle these problems. So similarly, you know, the ReproNim group has created this instructor training program and has created a ton of teaching materials that are kind of increasingly becoming used alongside kind of software carpentry materials as teaching aids on a bunch of fields from, you know, the basics of data management to building pipelines and doing statistics. There are also bootcamp programs like Neuro Academy, which take place in the summer, and the Brain Hack School, which is in Montreal, but I couldn't quite find a logo for, that are, again, essentially intensive blocks of times where students come, they show up at a workshop, and they just learn. And that's the whole point. So, let's see if next works. There we go. And of course, there are tons of resources I didn't mention here. This list, by the way, was just created all through Twitter, through like tweeting threads in preparation of the hackathon this year. And I didn't actually scroll to the bottom of the list. I just gave up on clicking the button and scrolling because I figured you'd get the point. So these are tons of resources that are available, some tutorials, some tools, what have you, but the whole point of this is to illustrate that there's no shortage of things to try and help. But all of that being said, perhaps the biggest barrier towards adopting these practices is that imposter syndrome is real. And I think it's very easy when you haven't been in this field very long, haven't been using these practices, to think, you know, everyone else knows what they're doing, everyone else is perfect, but I don't. And I think it's important to recognize that, you know, that isn't the case. You know, no one knows all the answers, and to be easy on yourself. You know, I think a common belief is that people believe they're held to a higher standard when they're open because their work is visible. But I mean, whether or not that's true, I think what at the end of the day it would do, even if that were the case, is it would make us all better scientists because of it. So I think it's important to be easy on yourself, to ask questions, and to give lots of feedback, especially on how to get into this community so that the community can continue to grow and foster, you know, more of this experience. And again, the only way to start is to start. So again, this in kind of summary of what I was saying, you know, there are many ways to be open. There are many tools, many data sets, many resources, and many people that want to kind of help you be there. It's just a matter of having interest and getting started. So I'd just like to acknowledge, of course, the rest of the SIG, the sponsors of this year's hackathon, you know, all the communities around this, like the Brain Hack, Slack, and Mattermost, ReproNim, and of course, the Science Twitterverse. And thank you.